Okay, so we're going to start with the first page on 45, 45, 90 special right triangles. And I did drop in our study guide notes over here on the side. So if you notice right here, here's the relationship in a 45, 45, 90. Notice that, excuse me, that little, let's make that smaller. Notice that this side length is going to be equal to this side length. It's technically an isosceles triangle because we have two equal angles and two equal sides. So whatever value this side length has, those two sides are equal. Then this hypotenuse is going to be equal to that side length times root 2. So they have a 1 to root 2 ratio or relationship. So we just need to find the side length, and then we can get the hypotenuse by throwing a root 2 on the end. So let's look at number 1. Number 1 has a side length already on there of 17. So we know that this other side length is also 17. Now that we have the two side lengths written in, we can go ahead and write the hypotenuse of 17 root 2. So again, what's this relationship? This is my side length, this is my side length, this is my side length root 2. Now there are several on this worksheet that are this easy, where you're just filling in the other side length and the root 2. So for example, if I look across this worksheet, which other ones are like number 1? Number 4 has a side length already given to us. Number 8 has a side length already given to us. Number 9 has a side length given to us. Number 13 has a side length given to us, just a nice whole number. That's the easy ones I'm talking about. And then that's it as far as the easy basic ones. So let's go do those first. So again, they gave me the 20 as the side length, so I know this other side length is 20, and then I know the hypotenuse is just the side length root 2. Okay, looking down at number 8, if the side length is 1, this other side length is 1, and the hypotenuse is just 1 root 2. Do I need the 1 there? No, technically I can just put root 2. Number 9 has a 12 as the side length, another 12 is the other side length, and that makes the hypotenuse 12 root 2. Are you starting to get the hang of this? This has a 13 side length, so the other side length is 13. So the hypotenuse is 13 root 2. And that's it as far as those nice easy ones where they already gave us the side length. So what happens on the other ones? What happens when they get weird? So let's look at number 2. And number 2 is similar to number 1, except that it's going backwards. They gave me the hypotenuse, and now I need to work backwards for the side lengths. So if my relationship is that this is equal to the side length, and this is equal to the side length, and this is equal to the side length root 2. Do you see that my side length is actually just 2? So here it is, 2. Looking at number 3 has a 4 root 2 as the side length. Here's where they start to get a little bit weird. So 4 root 2 and 4 root 2 are my two equal sides, and then I just need to go work out the hypotenuse. The hypotenuse is equal to the side length times root 2. Well, my side length is 4 root 2, and then times another root 2. So that's going to be 4 times the square root of 4, or 4 times 2, or just 8. So my hypotenuse for number 3 is 8. Okay, so that one used a little bit of extra work. Do you see what I mean? How it wasn't just as straightforward as number 1 or number 4 or number 9? Okay, let's go check out number 5. Number 5 is kind of like number 2. We know that this is the side length, and this is the side length, and this is the side length root 2. So do you guys see how the side length is just 10? So here I go, filling in, this side length is just 10, and this side length is just 10. So this one, again, is one of the straightforward ones. It's just working backwards. You were given the hypotenuse, and then you had to find the side length, which was a nice, easy 10 right in front. Okay, number 6. This time they gave us a hypotenuse as 3 root 6 instead of a root 2. So I know that the hypotenuse is the side length times root 2. So could I break up the 6 into something times 2? Well, yeah. Isn't 6 another way of saying root 3 times 2? So here it is. My side length is just going to be 3 root 3, which is the side length value in front of the root 2. Okay, on this next one, the hypotenuse is given as 6. So if I go 6 is equal to some unknown side length root 2, I can then go ahead and divide out that root 2 to solve. Now we just did a little notes on rationalizing the denominator. I cannot leave a root 2 in the denominator. So taking a root 2, multiplying by root 2 over root 2 will help me rationalize that denominator. We get 6 root 2 over 2. We get 3 root 2. So my side lengths are 3 root 2 and 3 root 2 when my hypotenuse is 6. Okay, going down to number 10. Number 10 has a 5 root 8, so that gives me another 5 root 8 on that side, and I know that the side length is my hypotenuse is the side length times root 2, so it's going to be 5 root 8 times root 2, which is 5 root 16, or just 5 times 4, or just 20. My hypotenuse on this one is 20. Okay, 8, breaking up the 8. Do you see how we could take the 8, split it up into 4 times 2? And the square root of 4 can come out, leaving you a square root of 2. So square root of 4 is just 2. Well, there's a 6 in front. So I just simplified this radical on the hypotenuse to 12 root 2. Now do you see that my side length, after I simplified, is just going to be 12. Okay, on this one, 9 root 2 is the side length, so 9 root 2 is this side length. So my hypotenuse is always going to be the side length times root 2. So we're going to go 9 root 2 times root 2. So we're going to go 9 root 4. The square root of 4 is just 2. So my hypotenuse is 18. All right, this one gave me a side length of 2 root 18, so the other side is 2 root 18. Remember that the hypotenuse is just that side length times root 2. I'm going to do the work on the bottom just so it doesn't get confusing with the other work on the top. So I'm going to go 2 root 18 times root 2, which is 2 root 36, and the square root of 36 is just 6, so my hypotenuse is 12. Okay, 6 root 12, 6 root 12. That means that my hypotenuse is 6 root 12 root 2. So that's 6 root 24. And can I break the 24 up into anything that can be taken out? Simplify that radical? Well, yeah, 24 is 4 times 6. So root 4 is just 2. So 6 times 2 is 12 root 6. So the hypotenuse is 12 root 6 in number 15. Here's a 5 root 6. That makes this 5 root 6 times root 2. That makes 5 root 12. I can simplify that radical, root 4 and root 3. A 2 comes out to 10 root 3. Okay, here one gave me a 3 root 8. So if 3 root 8 can be broken down into root 4 and root 2, do you see how the square root of 4 is just 2? Or 6 root 2. So now that I've got it in a form with a root 2, I can see that my side length is just 6. 2 root 5 is equal to the side length root 2. So this time I'm going to divide by root 2, and I get 2 root 5 over the square root of 2 as my side length, but I need to rationalize that denominator, multiplying by root 2 over root 2, and that's going to give me 2 root 10 over 2, and the 2's cross out, and it just leaves me root 10 as both my side lengths.